Hello, my name is Una Kearns. I am a Director of Technology with IIG. In this series of videos, we will demonstrate building an insurance onboarding application enabled with big data. This is an application that illustrates how companies can leverage EMC technologies to benefit from this next wave of information management, where information, big data, analytics, process and collaboration can be mashed up into an application that drives strategic business transformation. This application is built using our new XCP 2.0 application composition platform, Document Sciences, our customer communication platform, and the GreenPlum Unified Analytics platform. These technologies are all part of EMC's big data platform. Isilon for big data storage, GreenPlum Unified Analytics platform for real-time storage and analytics on massive amount of both structured and unstructured information, and the IIG product suite, our XCP 2.0 platform that allows the rapid composition of process and big data enabled applications, and Document Sciences that allows big data insights to be communicated to customers. The auto insurance industry is one industry that is seeing a strategic transformation with big data. It is also an area that is a traditional application space for IIG products. Insurance onboarding and claims processing. Traditionally, pricing and risk for customers was determined based on analyzing insurance applications and running credit checks. Ideal pricing would more accurately reflect percentage of losses, but this is hard to predict. Telematics have a large impact in this area. Telematics involves using devices in cars that monitor how a person is driving. This information is then sent at set intervals over the internet to the insurance company. The company can then analyze this real-time driving information to more accurately determine ideal pricing. Telematics also opens up the opportunity for new types of services and offerings, such as theft alerts, marketing offers, driving reports, and so forth. Social media big data could also be analyzed to gain even further knowledge of customers. Let's take a look at the main components behind the big data demo we will show you shortly. Firstly, a customer is signed up using an XCP insurance onboarding application. Forms guide picking insurance options. Document Sciences is called to generate welcome packages, contracts, telematics installation guides, and so forth. When a customer starts driving, the telematics data is sent over the internet to the GreenPlum Unified Analytics platform. As you can imagine, this ends up being enormous amounts of information. As for each driver, they are sending up second or minute by minute details of how they are driving, where they are, speed, ignition, battery details, and so forth. This information is then mashed up with other data in the GreenPlum Unified Analytics platform. What are the road details? How curvy are they? Are they dangerous roads? What's the weather like? And so forth, to accurately create a customer profile for how they are driving. Data scientists use analytic tools to develop models for customer profiles. These analytic models can then be very quickly executed in the database. On the XCP side, developers can use the new XCP Designer tool to compose this insurance application. The application you will see did not involve any coding. It was purely a composed application. The XCP platform allows the creation of what we call data services. These are abstractions for connecting to other data sources using standard interfaces such as JDBC, web services, etc. XCP connects to GreenPlum using JDBC, and Document Sciences expression using web services. The integration between the systems are created using stateless processes within XCP, which is a new invention in XCP 2.0. Document Sciences also has a friendly user interface Espresso Designer for designing sophisticated custom communication. We will look at all of these components in more detail later. Before we move on, let's maybe take a look at a sample of telematics data. Here you can see that what we capture is what's the address, what is the journey, did they start the journey, the time, the speed, what was the course they were doing, whether the ignition was turned on, and other types of information. Before we actually look at the application, let's take a look at what are the main logical components within the GreenPlum Unified Analytics platform. This is where, remember, that telematics data is actually sent from the car into this system. At the core of GreenPlum is the GreenPlum MPP database, and there's also GreenPlum Hadoop, which is more geared towards unstructured information. These database and Hadoop can be mashed up together, and queries can be executed across both systems, allowing you to mash up data, for example telematics data, with weather information and maybe road details and so forth, to overall create an accurate profile of how a customer is driving. There is a data access and query layer using standard interfaces such as JDBC and so forth, but the actual query language allows accessing rich analytic functions using libraries such as MATLAB. And this is through this layer is how we connect from IIG from XCP into GreenPlum, leveraging their JDBC interface. There are also a number of partner tools and services offered over the GreenPlum system, and many data scientists and so forth or BI analysts might like to use standard BI and analytic tools to create models. On top of all this is GreenPlum Chorus. This is basically a whole collaboration platform allowing data scientists and business analysts to collaborate in developing models to drive insight from big data. So for example, Chorus would be used to figure out how to develop a model for customer profiles and going off different data sources over GreenPlum. What we'll do next after this is view the application.